Hello and welcome today to another very wonderful class. We are going to be looking at biology today. So I'm going to quickly go to the platform we are using, and I'm going to go to all courses. Make sure that you've clicked on student registration and registered as a student, and log in using your login credentials so that you can be able to follow these classes effectively. Once you're registered as a student, then you can be able to check us out, be able to see stuff that we'll put up there for you. So I'm going to scroll down. I'm going to get to biology. You can see this biology here. That's the one we're using. And in the last previous class, we looked at what living things are. We say that living things are those things that have the following characteristics represented by the acronym Mr. Niger, movement, all those things that can move, respiration, growth, nutrition, all those things that have those characters, they are known as human living things. I would say that the biology is simply the study of those living things. I would say that the word biology is from two Greek words, bio meaning life, logi meaning logos, which means study. Discourse, logos, discourse, study. So when you're taking a discourse into life, when you're studying life, that is biology. And that is how that word came about. Okay, I hope you know that. Okay, so we say that this biology can be divided into two broad categories of study. We have the botany. Botany is for the study of plants. Call it botany, you can call it botany, you can call it botany. Just call it anything you want to call it. Call it botany, botany. That's the study for plants. Then you also have zoology. That's the study for animals. So those are the two major categories of living things, study of living things. Then we'll check out the characteristics of living things. We say that all living things, all of them move, all of them respire, Mr. 9, all of them nutrition, they feed, 9, all of them irritability, they respond to stimulus, 9, all of them growth, all of them excretion, they remove waste product, excretion, Mr. Niger, D, and finally R, all of them reproduce, and D, all of them die. They die in the end. So Mr. Niger D is the characteristics of all living things. So for you to call anything a living thing, that means that thing must exhibit these characters of movement, which is changing position from one point to the other, respiration, ability to take in oxygen in order to help in breathing, take out carbon dioxide, Mr. Then Niger D, and nutrition, ability to take in food, to supply the nutrients the body needs in order to grow, nutrition. Then irritability, I, ability to respond to stimuli, so that whenever they bring something hot, you'll be able to remove your hand before that thing burns you. They bring something like an acid that is corrosive, you're able to feel it and remove before it starts corroding your hand. Irritability, ability to respond to stimuli. When you get to a place that is very hot, you're able to leave so that it doesn't cause problem to you. Then we'll talk about Niger growth, ability to increase in size. Excretion, ability to remove toxic materials from our body. Then reproduction, ability to give birth to young ones, and the death, dying after the whole thing. So those are the characteristics of living things. Then we went further to learn about classification of living things, where we learned about the kingdom, the phylum, the class, order, family, genus, and the species. And we said that every living thing have a naming system known as the binomial nomenclature, where the genus name is picked together with the species name. And that's why human beings are regarded as Homo sapiens. Okay, so those are the things we looked at on the living things. There are plenty classification of okay. Those are plenty videos on them. Okay. Let's have right up on that one. Check it out. Okay, the right up is the first one. Interesting. Please, let's play this video a little bit. Let me feel this. This is a summary of classification. Wow. Never knew I had this. Okay, that means I have. Look at this. Okay, there's characteristics of living things. Calophyta bryophyte. Okay. Sorry. Okay. So what I was trying to say there is that there are 5 major kingdoms. We have the kingdom Monera, kingdom Protista, kingdom Fungi, kingdom Plantae, and kingdom Animalia. Then under Monera, and Moneras are single-cell microscopic organisms. They are known as prokaryotes. And under there we have bacteria, blue-green algae, and okay. Then we have protistas, also single-cell, known as amoeba and chlamydomonas. Then we have the fungi kingdom, made up of molds, mushroom, and the slime mold. The 4th and final are the major classification, the Plantae and the Animalia. Under the Plantae, we have the Talophytes or the Talophyta, we have the Bryophytes or the Bryophytas, and the Tracheophytes. The Tracheophytes are the most developed, under which we have the ferns and the seed plants. Ferns don't bear seeds. Then we have seed plants, the ones that bear seeds. But under the seed plants, we have the gymnosperms and the angiosperms. And finally, we have the kingdom Animalia, under which we have majorly invertebrates and vertebrates. Vertebrates have backbone. Invertebrates, they don't have backbone. Examples of the ones that don't have backbone: flat ones, round ones, annelids, mollusks, arthropods, echinoderms, and coelentrates. Invertebrate, they don't have backbone. Then we'll talk about the vertebrates, which include fishes, those ones that have backbone: fishes, amphibians, reptiles, birds, and mammals. Okay, this is incredible. So those are the major classifications. So take note, we have the kingdoms: Monera, Protista, fungi, plantae, and animals. Under Monera, we have the bacteria, blue, green algae. These are the most microscopic of animals. Whereas under the Protista, we have amoeba and chlamydomonas. Then under fungi, we have the mushroom, the molds, and the slime molds. And under plants, we have the xylophytes, bryophytes, and tracheophytes. Tracheophytes are more developed. Just under there that we have the seed plants and the ferns. Then under the seed plants, we have the angiosperms and the gymnosperms. Whereas for animal kingdom, we have majorly the vertebrates and the invertebrates. Under the invertebrates, we have flat one, round one, annelids, mollusks, arthropods, and the rest. Then under the vertebrates, we have the birds, mammals, amphibians, and the rest. Okay, incredible. Let's check this out. Sorry. So classification is very important. Okay, this was the classification. This was the one I talked about. Okay, I like the way all design. Like for real? For real? So please, we have kingdom. Yeah, thank you. See you when I see you. Thank you all. So we have kingdom, phylum. Another word for phylum is division. We have class, order, family, genus, and species. Organisms under the same species can have intercourse and bring new ones. Take note. You don't have close. Loxodonta africana, African elephant. Zimets. Wow, this is incredible on that classification, okay? Um, okay, so we have this kingdom Monera, which contains unicellular organisms known as prokaryotes having one cell. Example is bacteria. This is the example of a bacteria. Then we have the amoeba. Please take note of the shape of this amoeba. And this Euglena viridis, you're always gonna see this. In case if you're given this diagram, you should be able to know. Please take note. I want us to look at these various organisms. This is how a bacteria look. You have the flagella, you have the ribosome on the inside, you have the cytoplasm, you have the plasma membrane, you have the cell wall, DNA is at the middle. Okay, similar to this. Flagellum, capsule, plasma membrane, cytoplasm, ribosome, DNA, amoeba, euglena, chloroplast, nucleus, nucleons, flagellum, stigma or the eye spot, contractile vacua, polysaccharides stored by photosynthesis. Is a green plant. Yeah, Chika, you want to say something? Paramecium,
Good evening, sir.
Monstrum.
Can I hear me?
Yeah, please, I can hear you.
So we'll be starting our NECO practical on Monday.
Okay, NECO practical on Monday.
Yes, sir.
Wow, interesting. Which subject?
Physics.
Physics.
Yes, sir.
Okay. Physics practical. Let me think. Do you people have a lab in your school? You have a lab?
Yes, we're practicing in school today.
You said? You were practicing in school today?
Yes.
Okay. Like,
mechanics.
You people did practical mechanics?
Yes, and electricity.
and electricity, very important. Magnets and electricity.
There's also light, but they said we should choose two.
Also, okay, there's also light.
Yes, and they said we should choose two. So I'm choosing mechanics and electricity.
You don't like light because you're going to do reflection and refraction. Okay, picking out readings in light sometimes could be. In fact, when I did my own waec, I did light and I did magnets. Under magnets, I did simple pendulum. Right? Did you guys do simple pendulum?
Yes, sir, we did it.
Under light, I can still remember vividly what I did in my way, and I made my physics A1. Like I did light. The light I did was this prism block. Did you guys do that?
Rectangular prism.
You said?
I did the rectangular prism.
Rectangular prism, that's what I used. Like they gave me one rectangular prism. So we now put
the rectangular block.
We put pins. Then we are now trying to view it from this other side, like refraction. That was what we did.
That one.
Good. Rectangular prism.
Now you use mom's phone. Oh. Sir, can you hear me?
Yeah, Mona, sorry, somebody called me and I was using the network from my phone. Yeah, so like I was saying, the prism, the rectangular prism experiment is pretty easy. You just have your white paper that is on the board or your cardboard. Then you place your prism. Then you now use your ruler and locate the points. Just draw the points. Then put your what's it called, your pins, and be able to view it. Then once you're viewing it, any point where you are seeing one pin and you are not able to see the other pin behind it or the two other pins behind it, that's that place where you put this pin now. Then once you put it to, you now put a second pin. Once you view and you cannot see the other pins are the behind, then you put again. That's how you know. So when you now remove your eye, you now use your what's it called, the ruler and pencil to connect those points. Then you know where they are supposed to. Then you can now calculate the angle and do your further calculation. I don't know whether they taught you guys well. Did they teach you well there?
Yes, sir, they did.
I think I can't hear you. I don't know. I'm not hearing you.
I said yes, sir, they did.
Okay, please off the phone.
Sir, did you hear me?
I think you're on mute, so you have to unmute your mic.
So. Sir, can you hear me?
Yeah, I can hear you now. Okay. So Chika, that's how they do that's how the practical is done. Then the other one, I can remember that light so well because like I really enjoy the light. But you say you don't like light, you want to do electricity. Which one are you doing on electricity?
I prefer electricity.
Yeah, which particular one did they revise with you people on?
In light or on which one?
I mean electricity, for electricity.
Electricity. The one with resistant box.
Resistant box. I remember because some of my friends, that's the one they did. I didn't do that. Like
Did they
you
pass?
guys already.
Sir, did they
You guys
pass?
are already gonna. You said.
Your friends that you did with the resistant box, did they pass well?
Yeah, I think it depends on the one you understand. Though I think they also did well. Some of them did. I wouldn't like really remember what they are. It's been pretty long time. Like can't remember what their performance was like, but it was okay. Then which particular one did they show you guys on Mechanics?
Like single pendulum bulb, but we use mass this time. We not use bulb.
You see, it's almost
With
like the
our
same thing. Like
stopwatch.
and stopwatch, like yes, you use stopwatch to know when the swinging starts.
We
Like
have heat cock and the other stance.
Yeah. So like it's not gonna be difficult. Like once you enter, like don't pay attention to the long story that is inside the question. The question they are gonna ask you, the story might be so long. Don't pay too much attention to the story. Just go ahead to doing what you've been taught today and start solving out. As you're now solving out, then you will not be looking at the question. Then it will be bringing together what the examiner wants you to do in the solving. You're gonna, as you're doing it the way you were taught today, just once you enter, just start doing what you were taught today. Then as you're doing it now, be looking at the question. Then you can now relate what is on the question with what is what you're actually doing. Then from there you can simply get the simple calculations to do for that very practical that you've done. But practical is not normally an issue. Like the proper assistance is supposed to be given by your physics teacher that is handling your practical. Is supposed to be able to like lay in the basics for you guys to know the direction to move in. I hope that is how it is done.
Yes, sir.
Okay. So I don't think you're gonna find it difficult. It's not gonna be difficult. Like your lab, is it so big that one person can handle his own specimen and carry out his own practicals on his, or you like have 3 into 1 setup or 2 into 1 setup?
I think we're doing it 3 into 1 setup.
Wow. In our own time, we don't have anybody. In my own time, like we had to sit separately, like everybody to his own setup. Like our lab is so massive and we had plenty equipment. It's in a government school, senior science school. So like everybody was on his own setup. Like you have to have your specimen, have your own. If it is chemistry titration, you have your own tripod stand to yourself. As the students, we are not many. We are just very few. But if you have to have like some people to one setup, then it becomes even more easier. Like you can be discussing why you are trying to figure out what you want to do.
But the bad thing is that you might get the same records, and NECO would think otherwise.
Yeah, that's true. That's true. That's true. That's true. That's true. Well, it's not a problem in practicals. Like for a practical that a group of people did in a particular lab, there's tendency for there to be similar reading. But for different schools, if it is something that involves chemical, like for chemistry, there could be differences. But for physics and in a very particular environment, very specific environment, there's likelihood that everybody's gonna have similar readings. Then you now have to show out that your stuff is different from the other person with the way you lay out your answers. Okay.
Yes, sir.
But the readings are supposed to be basically similar. Like if you're doing light, if it's a problem in light, it's expected that everybody's reading will be so similar because light is light, refraction is refraction. So all those ones are consistent. Like if it is electricity, the same form of electricity is being delivered from every outlet in the country, normal 240 volts. So similar readings with very similar apparatus. Then the only place we could have the small differences is in mechanics, where the environments could differ, like from people that are in just Plateau State and other places might, because of just the environment, the air, the humidity might just affect just a little bit. But physics practicals, the readings are very close together. It's not going to be much difficult. Like I said, once you enter, like, assume that what you're seeing there is exactly what you've already practiced today. So start by doing what you practiced today. Then be taking down readings as you're doing. Then as you're now sorting it out, watch to look at what is exactly on your question paper, and make sure that what you're laying out is close to what is on your question paper. Are you there? Are you there?
Sorry, I didn't hear you.
Did you get what I was trying to say?
No, I didn't get your last word.
Okay, so I was saying that since it's physics, that similar readings are possible, especially for electricity and light. Electricity and light are just going to have the same answer for everybody that did it very well. The what's it called? The reading gotten from the practical is going to be exactly the same, except on the way you lay out your answer, as we have possible differences. The only place is the mechanics that you might have some slight differences from place to place in Nigeria, but the readings from light and what's it called, and electricity are just going to be the same.
Okay, sir. Thank you.
Okay. So the practicals are coming up on Monday. Is it Monday or tomorrow that is Saturday?
Monday.
Monday, okay, Monday. Monday is not a problem. I don't even know why NECO is coming first before waec.
I'm surprised too.
Huh?
I said I'm also surprised.
Like, it's very surprising. Like, it's supposed to be waec before NECO, but I think it's because of this corona lockdown thing that shifted things and reorganized the whole. Even NAPTEP that used to come very late is now, I think NAPTEP, they even did NAPTEP before also. I don't know. So it's somehow, but it's okay. It's okay. So now NECO comes, then after NECO you have your waec. Sometimes waec used to be more interested than NECO in terms of like waec you're more used to it than NECO, but NECO used to be like, NECO is a little bit lighter. NECO is not as difficult as waec. NECO people used to just get all the NECO, but they don't really get it as they might not just be getting A's, but they will just pass everything and get CCC. Then in waec, they might just get A's in some, and then some they will just fail. And I don't know. But I feel NECO is lighter than waec in terms of difficulty. Yeah, Oluwaseyi.
Good evening, sir.
Yeah, how are you?
Fine, sir.
Okay.
Please, I want to ask Chika a question. She said in her school that the practicals are done in sets. Is it in her school, or like is NECO that allowed it?
No. Yeah, Chika, you can answer. Yeah.
I think it depends on how your lab is, if it's big or small.
Yeah, if it's big enough, yeah. Some
Well,
people
I
you
thought
Still,
part of time they're allowed to use maybe biology lab or chemistry lab, should in case you can use other labs too.
yeah, that is also possible, I think.
yeah, it's
Just
also possible.
Okay.
Yeah.
Thank you.
Yeah, you're welcome.
welcome.
Okay, so like I said, in practicals are not physics practicals, okay? They are not something we should worry so much about, like I said. So once we get into the hall, like we choose the ones, we are going to have 3 to choose from 2, and just pick out the ones that you're very comfortable with. Then make sure you look at the attendant questions. There are some questions that come along with the experiment. So look at them and see that there are things you can solve so that you can just, as you're getting your readings, you're now giving them those things. And in this practical, you're going to find out that you have so much time or you have so less time. So make sure that you're focused in getting your those attendant questions that follow each of the practical. Make sure that you sort them out. So once you're working and you feel that you're already below the time, the speed that you need, you just focus on sorting out those questions. So get the reading and use the reading and sort out those attendant questions. Make sure you organize your work very well. Let it look fine. Let it look beautiful. So that when the examiner is looking at your work is organized to help you to get more score. You can easily script down what you want to write on the main paper, the question paper. Then later you just arrange it well. Maybe when you're better sure that the reading that you've gotten is the right reading, so you now use it and solve out the attendant question that follow that very particular question.
Okay, sir.
So you see now, once I type physics practicals, you can see on electricity, on simple pendulum, on light. These are the 3 main physics practicals that you can have for physics. So I'm going to click on electricity. And I'll come here and type physics practicals on simple pendulum. That's the next most famous one. Then I'm going to also type now physics practicals on light. Okay, those are the 3 most famous. Okay, so you can see this refraction, mostly refraction with Prism. Okay, I think this is perfect. Let me, supposed to play in a new tab so that I can get back here and, okay, let me look at this. Perfect. So this is the one I did on Prism, on rectangular prism. Chika, can you see this? Chika, you
Yes,
see
I
my
can
screen?
see. Yes.
Because this is exactly the one I did. Like I placed the prism here, then I now draw. You'll be allowed to draw this line by yourself because you'll be given the angle. So once you draw this line, once you place your prism, or once you draw this line first, the horizontal of this, so that you can know where you place this prism. Then you use your compass and draw the angle that is given to you. Then you now put these two pins here. Then you go to the back here now, as you now bend down and you're looking at it. So you check whenever you are seeing one pin and the other pin is directly behind it. That's where you locate where you put this one and put another one before you now draw. Take the two pins, once they are connected, where they hit up with the what's it called, with the center of this prism, becomes where it is. That's where you know your refraction, so that you can do calculation on your angle of refraction. Let me play. I should not just play this one. You said you're not interested in this one, but
Yes, sir.
okay, you're not interested in this one. Let's check out the ones you're interested in. These for simple pendulum, and these for electricity. So you said the electricity is on resistance.
Yes, sir.
Let me check out these first. Chika, can you see my screen? Can you see these apparatus? Are they similar to the ones you use for pendulum?
Yes, sir. But I used like the mass instead of the bulb.
A mass instead of a ball. Okay, it's still the same procedure.
Yes.
Yeah.
Yes, sir.
You had a stopwatch, bar?
Yes, I did. And we were counting as it was going, like we use spring. We use a spring, so we're counting as it was going vertically up.
Okay.
You know, usually in simple pendulum bulb, as it's going horizontal, you count 1, 2. But this one we're counting vertically. As it goes up,
Yeah,
we
because
count.
because it's a spring. That's in essence what you did was a simple harmonic motion. Abby? Abby?
Yes,
you did a simple harmonic motion. So you know this very apparatus that is down here. What's it called?
Yes, vernier caliper.
Vernier caliper, yeah. This is a meter room. Just like we did it the other time. This is a meter room for taking bigger lengths. Whereas you use the vernier calipers for the smaller lengths. Let me even play it. Okay, it doesn't have volume. So this is clamp. Like, did they give you guys clamp?
Yes, sir, they give us.
Okay. So maybe before the day, the clamps should have been set out for you guys, but you should also know how to use it.
Yes, they will like remove the clamp, then it's be us that will fix it.
Okay. Want to measure the diameter of the bulb.
So sorry, what did you say?
No, I'm just running a commentary on what he's doing. I said he wants to take the measurement of the diameter of the bulb. It should be 1 point. Okay, the effective length. The distance between the point of suspension and the middle of the bulb. That means the distance to the bulb and the radius joined together. Now place the stand such a way so that the bulb is so now take note of the time taken for it to have some oscillation and displace it onwards. Time taken for 20 oscillations, okay? And the period is that, okay? Decrease the length. Try it again. denoting the effective length. So you put a ruler so that you make sure that the displacement is consistent for the most time that you're going to try it out. This is how you lay out your reading. Diameter of the bulb, you got it from the vernier caliper, and diameter over 2 is the radius. Next one is in the right millimeter. Second observation. Okay, for the first observation, the length of the effective length is 0.3. I mean, the length is 0.3. Effective length, which is the length plus the radius, is 0.313. Okay. And time taken to do 20 oscillation is 1.1. So the time is equal to 2 pi all over t. So where pi is equal to 3.142. So you sort it out. 4 pi squared by t, okay? For the first observation. And for the second observation, L is 24. This is the time. L, effective length. Okay, gotten from the radius plus that gives you the effective length. Then you put back in the G. So when you substitute, you get now 9.3. Okay. So you take the average of the two G's, 4G plus the second G all over 2. I think this is pretty surface. It's easy. Tika, did you make any sense of the?
Yes, it did, sir.
Okay, so it's similar to like the normal layout you would have had for your own. Let me look at this electricity. I'll be very good now. Let me see this first. So it's very, very important that you have enough confidence when you're about to start. Don't really be afraid. Take your time and breathe in, breathe out, and please give us what we want. I want to get one that is straight to the point. Okay, this NECO 2020. Okay, let me check out this. Okay, it's for the same physics of start making lectures on. Lectures on these practices. So these are so.
Is meter bridge.
So, Chika, were you guys given a diagram like this, a similar diagram like this for the one you rehearsed?
No, sir, they said they are not asking this one.
Wait, let me remove the volume here so that I can hear you. You said what? Chika, what did you say?
So I was saying that they said they are not giving us this one. Our teacher said they are not giving us this one. This is on meter bridge.
Okay, this is on meter bridge. This is not the one they are giving you. Good. Because your teachers are supposed to already have insight into likely practical. So it's good you take their instruction. Anything they tell you is likely going to. I don't think this one is close to what we want. Okay, but in essence, like I said, it has to be just similar to what you rehearsed today. That's what you're gonna see tomorrow. Similar to what you rehearsed today. So like I said, you have to be focused and similar to what you've rehearsed, practice. Then as you're practicing, do the practical. Then as you're doing the practical, you have to be making reference to the question that is asked. You look at the question that is asked and you use it to impact your practical. Okay, so this is where we are stopping. Wow, this class has taken a whole lot of time. I think because of the questions on our physics. I think please can somebody send me your timetable so that the subjects we'll be doing so far will be relating to the subsequent exams you're going to have. Like if you are going to be having a class on Monday evening, it should be relating to the exam you're going to be having on Tuesday morning. Tika, can you send me your timetable?
Yes, I'll send it. Okay.
Yeah, please send your timetable so that we'll make sure that we're exclusively studying for the NECO. So that if we spend like 10 minutes on normal study, then we'll spend the other time on likely things that's going to be coming out in our NECO. I believe that will be more enjoying. Oluwase, will you be more enjoying? Oh, Oluwase say it's not writing NECO. Okay, no, it's Blessing that says that. Oluwase, are you writing NECO? Oluwase, are you there? You're on mute in case if you want to talk and they're trying to talk and I can't hear you. Oluwase, can you hear me? I can't hear you. Okay, so that's how we move forward. Yeah, Oluwase, are you writing NECO?
Yes, sir.
Nice one, nice one, nice one, nice one. You guys are gonna blast NECO. I'm so much confident in you guys' ability in the NECO. Just like I said, make sure you arrange your work very well. Neatly write out your points. Make your points very clear so that the examiner, the marking person, when he's seeing it, it can see what you've laid out easily and it can give you your mark. But I trust your ability to I know, I'm so sure you people will smash the NECO, both the NECO and waec. Will smash it very well. Okay. So no, I'm not gonna give any assignments since you guys are already writing exams so that you can just concentrate and quickly pick up on what you're going to write, but just feel relaxed as you're entering these WAEC exams. Feel totally relaxed. Don't ever worry yourself. Don't ever worry yourself. You're going to do it well. Once you enter there, you start writing. Make sure you start writing. Start from writing things that you're sure about. Then once you lay out things that you're sure about, the inspiration to write the ones that are confusing will come into place. Then you just arrange them. Don't make too many mistakes, and it's gonna be okay. So I'm wishing you guys good luck. Good luck in your Monday exams, sciences.
Thank
Your first exam matters because it's gonna give you the right composure to take through the other ones. So I'm wishing you guys good luck. I'm gonna be praying for you as well. Make sure you pray for the exams, and I wish you good luck. You guys are gonna write well and you're gonna pass.
Thank you, sir.
Yeah, I'm gonna be signing off now. See you when I see you. Thank you. God bless you.